maximum frequency deviation of your FM modulated signal is max of your frequency deviation, that is kf of max of mt. Okay, this thing is quite clear. Now you want to see the structure of your modulated signal. So in order to get this structure, you have to find this theta it, right? You know from your plus 2 that instantaneous frequency is 1 upon 2 pi d theta it by dt. Correct? So theta it would become 2 pi integral of this signal, this frequency, this instantaneous frequency. So if you put FIU, value of FIT from here, question number A, by replacing FIU from equation A, here we get this step, 2 pi FC plus KF MU du, and we integrate it, so we get instantaneous phase at 2 pi FCT plus 2 pi KF MU. This is nothing but instantaneous phase of FM modulated signal. So here you can clearly see that phase is not proportional to mu but integral of mu. So this is the basic difference between FM and PM. But if it were PM, then the phase deviation means theta it minus 2 pi fct will be proportional to your massive signal. That you know from your theory classes. So just a recap. If you have any doubt, you can still ask. So what would be the structure of your FM signal? AC cos theta it. So we are replacing your theta it with this. AC cos 2 pi fct plus 2 pi k of mu. This is the structure of your FM signal. So you can take any mu, right? It can be square. It can be sinusoidal. So in case of here, we will take for our experiment sinusoidal signals, message signal. So if your message signal is sinusoidal of amplitude AM and frequency FM, for this particular scenario, the FM signal would become AC cos 2 pi fct plus, just put here the value of mu here. Sorry, you can write it in. So mt is this, so just we replace mt there and we integrate, so we get this equation. X of mt is AC cos 2 pi fct kf am by fm sin 2 pi f. This quantity is also referred to as modulation index, because it decides the depth up to which your message signal will affect your phase. See, if value of this is more, then slight variation in the message will affect the total phase of your FM signal more, right? That is why it is called modulation index. So as we define the frequency, maximum frequency deviation here, this is your maximum frequency deviation, right? So now we have, for a particular case of sinusoid, maximum frequency deviation is kf max of mt, that is max kf into am. And now you have already defined your modulation index at beta kaf fm. So you can also write as beta fm. Just I'm playing with the parameters. So what would be the instantaneous phase of your FM signal when your message signal is this? This is your message signal. So maximum frequency, maximum phase deviation अगर यहाँ से निकालें तो first you will evaluate instantaneous phase. Instantaneous phase तो पता है. This is the instantaneous phase. यहाँ पे put करेंगे value. After integrating, we get this, right? So what would be your frequency phase deviation? max phase deviation. Your max phase deviation, if you evaluate, would be K of AM by FM, which is nothing but the modulation index. These are the few important points which you should remember. We can ask questions in your quiz, so just be prepared. Huh? What is the max? So what we have discussed? What is the structure of a XFM signal, frequency modulated signal? 2 pi kf. In some books, you will also get minus infinite, so it's okay. Then, what is the frequency deviation? That is directly proportional to your masses, or it is K of mt. What is your Kf? Kf is frequency sensitivity. What is the units? Hertz per volt. Then we have seen that we can evaluate instantaneous phase. This is the instantaneous phase. What is the phase deviation? This is the phase deviation. Then we said, this is true for all the possible m's, right? It can be square, it can be sinusoidal, anything. But next we said, for a particular scenario when your message signal is sinusoidal signal. For the sinusoidal signal, we define what is the structure of XFM. Just use this formula, AC cos 2 pi FCT plus 2 pi KF. Integral of this is nothing but 2 pi FM AM sine of 2 pi FMT. So this gets cancelled, and this we called beta. This is modulation index. So see, this definition of modulation index or concept of modulation index is only true for sinusoidal type of message signals. Okay, so this point you must remember. So this thing we studied. And what else? What is the frequency, maximum frequency deviation? Kf mt. Kf max of mt, because we are taking max. Your mt is am cos of 2 pi fmt. So kf into am. So this is your maximum frequency deviation for sinusoidal signal. If I ask you, your sinusoidal signal is this, what is the maximum frequency deviation of your frequency modulated waveform? Then we discussed what is the maximum phase deviation of this. Maximum phase deviation is defined like this. See, because this is your instantaneous phase, and this is your so this is the phase deviation, right? तो बताओ क्या होगा for the sinusoidal case? 2 pi इंटीग्रल आपने किया, so you will get am cos को करेंगे sin 2 pi fmt divided by 2 pi fm. करेक्ट? af भी यहाँ पे रहेगा, I think. Just I missed kf here, right? So just nobody pointed it out, right? Everybody is sleeping. 2 pi kf. इसका मैक्स लेंगे, so it will be kf am by fm, which is same as the modulation index. The concept of modulation index is only true for the case when you take message signal as the sinusoidal signal. Always remember this. Above this theory is true for all the massive signal. What's the maximum frequency deviation? What is the instantaneous phase deviation? What is the instantaneous phase? These things are defined for all the massive signals, but this concept of beta is true for sinusoidal signal only. So this is the modulation part. Let's first plot the modulation, and then we'll see the demodulation. Okay. So let's start go to the multisim. Everybody just open your multisim. Today it's pin drop silence. Nobody is asking anything. Nobody is telling anything. No? Okay. So I think you can make this diagram then. Just make it. Or should I explain?
Sir, please tell what the values in the particular components will be.
अभी बोले हो तुम लोग हाँ? It was just a bluff. Anyway, I was going to perform it. So you know this, right? Sine. So just take sine wave. Go to source, take sine wave. Just take this is your input signal, right? So let's take, because we are taking cos 2 pi by 2, right? So phase should be pi by 2, and we are taking 2 pi, maximum frequency component as 10. FM is 10. Just do it like this. Amplitude is 1, AM is 1. ठीक है, ये clear हो गया? It is actually a cosine wave. Next, see what we are doing here. We are just trying to generate this signal. So first we are generating this argument of, and we will provide this argument to this cosine function. This is what we are doing. So what is the argument? 2 pi kf integral of mt, right? Plus 2 pi fc. See, इसको देखो. Yeah, this one. This is your theta it, right? And our aim is to generate AC cos theta it with theta it as 2 pi fct plus integral of mu du multiplied with 2 pi kf. So this is what we are doing. So it is equivalent to 2 pi fc plus mu, sorry, two pi kf mu whole integral, right? This you agree, right? So first we are generating this argument, and then we will integrate, and then we will provide this phase to cosine function. So this is what we are doing. This is your cosine function. We are first generating this, and then this is integrator. So this is the argument, this is the integrator, we provide it to cosine. समझ में आया क्या कर रहे हैं? So just take a gain function. बताओ गेन की वैल्यू कैसे सेट करोगे? गेन की वैल्यू किस पे डिपेंड करेगी? थोड़ा बताओ मुझे.
रेशियो ऑफ आउटपुट एंड इनपुट.
फिर वही बात, ये मतलब गेन वैसा गेन नहीं है, इट्स जस्ट मल्टीप्लिकेशन फैक्टर. इसको ऐसे सोचो. अब बताओ कैसे डिफाइन करोगे गेन, वो फैक्टर? अभी मैंने बताया ना, इसको देखो, बताओ। 2 पाई के एफ एम यू, राइट? 2 पाई के एफ ए यू एम यू प्लस 2 पाई एफ सी को इंटीग्रेट करना है। दिस यू एग्री, राइट? इसको देखो, बोलो कोई दिक्कत नहीं है, जस्ट डिस्कस। दिस इज ऑब्वियस और नॉट? अदरवाइज आई वुड एक्सप्लेन इट अगेन। बोलो, क्योंकि we can tweak the question, right, in the exam. So if the concepts are not very clear, then you will face problem. I hope then it's clear. 2 pi kf, so kf की वैल्यू पे डिपेंड करेगा. So if we set kf to 50, so this is 2 pi kf, 2 pi kf mt. Now ये मैंने कोई गलत वेव ले ली क्या? एक सेकेंड. Force, we put sine phase I by 2. I think it's okay. The same, this signal is same, right? Yeah. So हो गया 2 पाई के एफ एम टी. अब नेक्स्ट क्या चाहिए हमको? 2 पाई एफ सी. If 2 pi एफ सी, so this is a constant. First generate a constant. एंड अब बताओ ये कांस्टेंट की वैल्यू किस पे डिपेंड करेगी? अगर मैं ये बोल दूंगा तुमसे कि कैरियर फ्रीक्वेंसी 1000 है या 100 है, तो कैसे सेट करोगे अगर पता नहीं होगा कि किस पे डिपेंड कर रहा है? अब बताओ. नहीं समझ में आ रहा तो पूछो. Now we want a sum. SUM. So now we have to integrate, right? This is your integrator. हम लोग अभी इंस्टेंटेनियस फेज जनरेट कर रहे हैं. टेक इन अ लॉग इंटीग्रेटर, पुट इट हियर. अब बताओ इसको किसमें? दिस इज द इंस्टेंटेनियस फेज ऑफ योर कोसाइन कैरियर, राइट? कहाँ है कोसाइन? तो इसको इनपुट, इसका फेज हमने यहाँ से सेलेक्ट कर दिया. So what do you think? Is this the output? Trigonometric function T. तो अब बताओ ये FM है कि नहीं? Is this frequency modulated signal or not? Is this a frequency modulated signal or not? बताओ. Anyone? चलो देखते हैं. ये है, इसमें नंबर ऑफ पोर्ट्स बढ़ा लेते हैं 3. सो फर्स्ट में तो यही मैसेज सिग्नल, थर्ड में ये, और कैरियर सिग्नल. तो कैरियर जनरेट करना है तो कैसे करोगे? व्हाट इज द फ्रीक्वेंसी ऑफ योर कैरियर? अच्छा ये तो बताओ, अदरवाइज मैं नहीं करूंगा आगे, फिर अपने आप से करना आप लोग. व्हाट इज द फ्रीक्वेंसी वी आर यूजिंग फॉर कैरियर वेव, बताइए. Anyone? बोलो निश्चय।
2 pi fc.
हाँ, FC की वैल्यू क्या चूज करी हमने, बताइए।
सर 50 and 100.
नहीं नहीं, 50 100 का के एफ की वैल्यू है। इफ योर वैल्यू ऑफ के एफ इज 50, तो हमने यहाँ पर पुट किया ना। देखो क्या कर रहे हैं हम यहाँ पर, ये कर रहे हैं ना, के एफ इज 50 एंड एफ सी इज 100। तो 2 पाई एफ सी प्लस एम यू मल्टीप्लाइड विथ 2 पाई के एफ, तो यही हो रहा है ना यहाँ पर। एम, दिस इज योर मैसेज सिग्नल, दिस इज योर मैसेज, दिस इज योर फैक्टर 2 पाई के एफ, 2 pi kf mt plus 2 pi fc. This whole thing is going inside an integrator. This is the phase, instantaneous phase of cosine. So first we are generating the instantaneous phase of your signal, then we are providing it to cosine wave. तो इसमें क्या प्रॉब्लम है? तो इसका फ्रीक्वेंसी क्या होना चाहिए कैरियर का, बताओ, 100 होना चाहिए ना। दिस इज अ कोसाइन वेव, ठीक है। तो इसको रन करते हैं। There is slight problem here. Not, this is your message signal. No, the carrier which I am generating is not proper. 1 second. Cosine is 2 pi 100, pi by 2, the total is 1. Second.
Sir, there are two integrators. Sir, which one are we supposed to use?
Analog integrator. Integrate. This one. I think both are same. Are they different?
Yes, sir. Sir, here it is written.
Continuous time integrator. Both are continuous time integrator, I think. Yeah, I choose continuous time integrator. I think I should also use this one. Maybe that is why signal was not correct. Yeah, thank you. You also solved my problem actually. I used the wrong integrator, that is why. No, still it's a problem. Let me check. What is
Sir,
bolo.
sir, I think you have to change the icons of these message signal and cosine.
Message को क्या करूँ?
Sir, there is one another option for it in the library browser.
Okay. I should choose this one, right?
You have choose this, but there is one another option also for it.
Okay. तो I'm getting only this. Fine.
You are not clicking on the searching option.
Okay.
So this one in the first
This
line.
one?
Yes.
Okay. Yeah. इसीलिए प्रॉब्लम आ रही है। इसको डिलीट करते हैं। नो, इसमें तो इनपुट आउटपुट दोनों हैं। वी वांट जनरेटर, राइट? इसमें तो इनपुट आउटपुट दोनों हैं, हमें तो सिर्फ जनरेटर चाहिए। It's okay, let me see my diagram which I have made.
सर हैंडआउट में जैसे इंटीग्रेटर की अगर डिस्क्रीट टाइम इंटीग्रेटर दिया हुआ है।
नहीं, इसको आप एनालॉग यूज करो।
ओके सर।
बस प्रॉब्लम ये मैसेज सिग्नल में ही आ रहा है, मैंने कुछ गलत साइन चूज कर लिया, अदरवाइज ठीक है। लेट मी सी, आई शुड चूज दिस। If I just copy it from here, two pi
So
10.
we have
Sir,
not
sampling
changed the
time.
sampling time.
Okay, maybe. Yeah, thank you. It's your carrier. Frequency must be 100. अभी हो जाएगा. Yeah, so you can see this is your message signal, this is your carrier signal, and this is your frequency modulated signal. How to verify this? I mean, how can you verify that this is your frequency modulated signal? You know from what is the frequency deviation, right? Or instantaneous frequency is fc plus k of mt. It means your when your m is positive at this point, see the cycle, the modulated signal is quite close, quite dense, and then it will start decreasing, and then when mt increases, again your frequency modulated signal would become denser, and at this point it will be most dense, right? And then again it will start becoming sparse. As you can see, instantaneous frequency is fc plus k of mt. So when your mt is increasing, your FIT will increase, and mt is decreasing, it will decrease. So what are the points where your frequency modulated signal will have the same frequency as the message signal? Batao. What are the time instants at which the frequency modulated signal would have same frequency as the carrier frequency? Look at this formula. When your mt is 0, then instantaneous frequency of your modulated signal would be same as the carrier frequency. What are those points? This. See, at this point, the frequency, the separation of the cycle will be same as the carrier, and then it will start decreasing here, and it will increasing here because mt is positive, here mt is negative. Just you have to look at this formula. So this is the frequency modulated wave. सबका हो गया यहाँ तक? अब बताओ, अगर मैं kf की वैल्यू 25 करूंगा तो कहाँ पे चेंजेस करने होंगे, किस ब्लॉक में चेंज करने होंगे?
सर फैक्टर वाला 2/50 जो है,
Why?
सर क्योंकि वो मैसेज सिग्नल से मल्टीप्लाई हो रहा है वो.
Yeah, because this is the gain you are providing to your message signal, right? That is why I called it gain. 2 pi kf is gain you are providing it to mu, and this is your fixed carrier frequency. So अगर मैं यहाँ पे आप चेंज करेंगे तो you have to change this. अब carrier frequency चेंज करने के लिए बोली जाएगी, then you have to change here, right? Because you are multiplying it here, you are providing gain, right? 2 pi kf mt. अब अगर we want to demodulate, so in order to demodulate our signal, frequency modulated signal, what we do, we use, what was the name of that device which I told you in the very beginning? Bolo. In the very beginning of our class, I told you that we will use phase locked loop, and this is a device for you. Just think it as a device that it provides you the same frequency and phase of the input wave. So this is your PLL. If this is a black box, what signal you provide here with some frequency and some phase, it will give you the same frequency and phase. That is why it is called phase lock loop. Now let's zoom in. I mean, let's see what's inside this PLL. PLL is consists of a voltage controlled oscillator, a multiplier, and a low pass filter. So initially क्या होता है, and this is your PLL. And inside you get multiplier, low pass filter, and VCO, and this VCO will oscillate with the same frequency, or this output of this VCO will be same sinusoid as you provide here. So initially क्या होगा, if VCO has some frequency, here you generate an error signal. And if your VCO का frequency शुरू में suppose यहाँ पर 10 हर्ट्ज दिया तुमने, और VCO की initial setting 6 हर्ट्ज थी, तो क्या यहाँ पे error positive आएगा, और this will give you indication that you should increase your VCO frequency to some value. So it will increase up to the point when this VCO frequency is equal to 10 hertz. I'm just giving a very broad level view, and in depth we'll study in your principle of communication course, I think, most probably. तो क्या है यहाँ, ये multiplier होता है. This is a multiplier, this is a low pass filter, and this is a voltage controlled oscillator whose frequency or whose output would become same as the input waveform. So if this is your input waveform, so after some time it will also capture this. Okay? Of course, there should be some properties which must be satisfied by this PLL in order to capture it perfectly. But we assume that this PLL is so perfect that it captures whatever frequency and whatever phase you give it to it, you provide it. ठीक है? तो चलो क्या बनाना है हमको, multiplier, low pass filter, and VCO. So let's take a VCO first. So VCO. Continuous time VCO. Let's search for it. This is our signal. Go to library wire. Continuous time VCO. Continuous. VCO. Discrete time VCO, continuous. Take this. Now you have to take a matrix multiplier. Multiplier की जगह now you have to matrix multiply. तो बताओ यहाँ पर क्या दूं, what should be the input of this? देखो कौन कौन से दो सिग्नल मल्टीप्लाई हो रहे हैं, VCO का आउटपुट और input, or the frequency, I mean, which you want to capture, or the frequency modulated waveform, right? Because we want to extract the frequency of this modulated waveform, right? Because information is embedded in the frequency. This is a frequency modulation, correct? So इसको add, इसको you have to correct, and then this output, so we have to flip it, right? Output of VCO, and now we have to take a low pass filter. Butter filter. just type analog filter and you will get a butterfly. Now let's take one more scope. Rotate and flip. So we want to see the modulated signal and demodulated signal. VC output is demodulated signal and this is the modulated waveform. So this you can see now that you have, this is your modulated waveform and this is your demodulated waveform. ठीक है, तो दो स्क्रीनशॉट लगाने होंगे आप लोग, तीन, one for modulation, one modulated and another one for demodulated FM signal and one for this schematic. अभी पूछो कोई डाउट है तो.
एक्सक्यूज मी सर.
हाँ,
सर कंटिन्यूअस टाइम वीसीओ सर आपने अपने लाइब्रेरी ब्राउजर में टाइप किया तो वो आ गया, बट हम लोग के में नहीं आ रहा. तो सर
सिर्फ VCO टाइप करो.
सर वो भी नहीं आ रहा. ऑसिलेटर भी टाइप किया.
नहीं नहीं, VCO मैं दिखाता हूँ. VCO टाइप किया, यहाँ पे आया होगा, देखो 1 2 3 4 5 6 7 8, थर्ड रो सेकंड कॉलम. आ गया. अभी मैं रिकॉर्डिंग ऑफ कर देता हूँ ताकि शुड नॉट बी वेरी लॉन्ग.